Hello everyone. In this video, we are going to talk about tests for parallelograms. In the first part of the lesson, we are going to talk about some conditions for us to say that quadrilateral is a parallelogram. First, let's go over these statements, and then in the second part of the lesson, we are going to talk about parallelograms on the coordinate planes. So the first if-then statement is if both pairs of opposite sides are parallel, such as side AB and side DC, and side AD and side BC. If these sides are parallel, which means if their slopes are the same, these two sides, and if the slopes of AD and BC are the same, then quadrilateral ABCD is a parallelogram. Or the second if-then statement is if both pairs of opposite sides are congruent, which means if their lengths are the same, like the length of AB and the length of side DC are the same, plus this is not enough, side AD and side BC must be congruent as well. Then we are going to say quadrilateral ABCD is a parallelogram. Another statement is that if both pairs of opposite angles are congruent, like both pairs, the first pair of angles are A and C, these must be the same. Also, angle B and D must be congruent. In that case, figure ABCD is a parallelogram. Another if-and-then statement, if the diagonals bisect each other, the diagonals are segment BD and segment AC. If these two segments cut the other one in half, then that means ABCD is a parallelogram. The last one is if one pair of opposite sides is congruent and parallel. So if we only know that, let's say this is the only pair that we know of, and they are parallel and they are congruent, then this figure is automatically becomes a parallelogram. So let's go over these statements. If side AB and DC are congruent, also if side DC and BC are congruent, that means the figure is a parallelogram. Another statement, the opposite angles are congruent, like angle A and C are the same. Also, angle B and angle D are the same. That's why I use different colors. Don't think that they have the same symbols. So the same colors are the same measures. And also, there is one more thing. The diagonals bisect each other. So let's take segment AC. It must cut DB in half, like this. DE and EB must be the same, and DB must cut AC in half, or we can use 3 lines on the parts of the diagonal. So I guess that's all for the parallelogram. So let's move on to the example right here. Find x and y so that FGHJ is a parallelogram. So we have the figure. If we look at the measures that we have, we realize that we know the measures of the sides. This side FG, is 6x plus 3, and side JH is 15 units. And I know that if this figure is a parallelogram, which it is, then their measures must be the same. FG and JH must be the same. One of their measures is 6x plus 3. It must be the same as 15. So we solve this equation by subtracting 3 on each side and dividing by 6. So x would be equal to 2. Now we know what x is. Let's figure out the y. Y belongs to side FJ and side FJ. And I know that it must be the same as GH. They must be congruent because this figure is a parallelogram. Now what I know, the left side is 4x minus 2y. It must be equal to 2. Because they are opposite sides, they must be congruent. If they are congruent, their measures are equal. So now, there are 2 variables on the left-hand side of the equation, but I know what x is equal to. We just figured it out. It was 4 times, instead of x, I'm going to put 2, minus 2 times y equals 2. The left-hand side becomes 8 minus 2y equals 2. We subtract 8 and divide by negative 2. So we would get y equals positive 3. Now we are done with this question, and let's move on. Here we have same type of questions, but this time instead of sides we are going to deal with the angles. we are going to do the same thing, which is finding the value of x and y when we have a parallelogram. So let's get started. Remember the properties that we just went over. One of them was opposite pairs of angles are congruent, such as this angle right here and that one right here. These must be congruent because the figure is a parallelogram. So if they are congruent, their measures, which are 5y and 25, must be the same. So we solve this equation by dividing each side by 5. Y would be equal to positive 5. Now once we do this, we can move on to the x. So I'm going to use another color for that. The angle right here, its measure is 5x. And I know that consecutive angles of a parallelogram must be supplementary. So solving this question is possible using two different methods, as I can see. The first one is these two angles are going to be supplementary, which means they're going to add up to 180 degrees, or this 5x degrees plus 25 must be equal to 180 degrees. Or the other method would be, which is using the properties of parallelograms that we just went over, opposite pairs of angles must be the same. So if this angle is 25, this corner is going to be 25 as well. So I'm just going to put 25 for right here, 25 degrees. And I also know that if this angle is 5x, that one right here would be 5x degrees as well. Now, since we have a quadrilateral, that means the sum of interior angles of a quadrilateral must be equal to 360 degrees. So let's add all of the angles that we see and then set it up equal to 360 degrees. So these two is 25 plus 25, right? If we add them together, we get 50. Plus, now we have these two angles. One of them is 5x plus 5x gives me 10x. And the sum of these four angles must be 360 degrees. This is what happens when we have a quadrilateral. It's always 360 degrees. So we subtract 50 degrees from each side. Left hand side becomes 10x. Right hand sides become 310. Divide each side by 10. X would be 31. We are done with this question. And let's move on to the next one. So we still have a parallelogram, which means the opposite sides are parallel, like this one and that one, plus this side and that side. These are parallel sides. So let's see the relationship between the angles. Like this angle here is x plus y degrees, right? And that one right here. So the name of this pair, x plus y degrees and 24, is alternate interior angles. So these are alternate interiors because they are between these two lines. That's why they are interior, and they're on the opposite sides of the transversal. This is the transversal, which is the line that cuts through the parallel ones. It cuts it. The right side is one of the angle. The left side of the segment is the other one. So they're alternate, which means opposite, or interior angles. Their measures are the same if we have parallel lines. So let's set them up equal to each other, x plus y and 24. They must be the same. But here we have another problem, which is, as you see on the left hand side of the equation, we have two different variables. But we only have one equation, which is not enough for us to solve this equation. We need another equation to move on. So let's check the other two angles, 30 degrees and 2x degrees. So let's talk about these angles. So if you consider just a second, let's imagine these lines are extended like this, the parallel orange lines. So both of these angles, 30 degrees and 2x, they are between the green lines. That's why they are interior angles. They are interior. And here is the transversal. Let me just see. Yep, this one right here. This one is the transversal. 2x degrees is on one side of the transversal. 30 degrees is on the other side of the transversal. That's why they are alternate interior. which means their measures are the same because the green lines are parallel. So if they are the same, 2x would be equal to 30. Divide each side by 2, we would get 15 for x, which means now we know what x is equal to, so we can plug it in. X plus y is equal to now 15 plus y. Now we are going to solve this equation. Subtract 15 on each side. Y is equal to 9. Since we have both of the values of x and y, we are done with this question. Now we can move on to the next one. Okay, next example is going to be about the second part of the lesson, which is parallelograms on the coordinate plane. So these type of questions are usually for us to prove if the quadrilateral that we have is a parallelogram by using the distance formula or slope formula, or sometimes the midpoint formula. In this video, I will talk about how to prove if a quadrilateral is a parallelogram by using the distance formula and by using the slope formula. So let's get started with the distance formula. First, I'm going to write a reminder here. The distance formula is equal to x2 minus x1 squared plus y2 minus y1 squared. So these numbers, x2, x1, y2, and y1 comes from the coordinates. We are going to label the coordinates as x1, y1, and for another point, we are going to label it by saying x2, y2. So let's get started, and I will explain how to do and what to do. So we are going to determine if quadrilateral ABCD is a parallelogram. When we look at it, yes, it looks like a parallelogram, but questions in geometry is not about how it looks. We need to show that it is a parallelogram. So the vertices are given for A, B, C, and point D. So what I'm going to do is I'm going to use the distance formula and show the opposite sides. Remember the first property of the quadrilaterals. The first property of parallelograms, the opposite pairs of sides are congruent. It might be the second property as well. I don't remember exactly. But so the opposite sides are going to be congruent, like side AB and side DC. So let's find the measure of side AB. The coordinates are going to come from point A and B. I'm going to say this is x1, y1, x2, y2. So let's subtract the x values. 3 minus negative 2 squared plus 2 minus 3 squared. So 3 minus negative 2 is equal to 3 plus 2. It becomes positive. So the first number is going to be 5 squared. Plus 2 minus 3 is negative 1. We are going to square that number. And please don't forget about the parentheses, because if you skip them, when you have a negative number like negative 1, the answer that you will get is going to be wrong. So 5 squared is 25. Plus negative 1 squared is positive 1. If we add these together, we get radical 26. Now, we need to prove that the length of DC is the same as the length of AB. So let's find its distance then by using these 2 points. So I'm going to say x1, y1, x2, y2. So subtract the x values, negative 3 minus 2 squared plus 0 minus negative 1 squared. Right here, negative 3 minus 2 is equal to negative 5 inside the parentheses. 0 minus negative 1 is positive 1. Now, if we times negative 5 by itself, it becomes positive, which is 25. 1 squared is 1 times 1, which is 1. So if we add these two numbers, we realize that the length of AB and DC are the same. Now we are going to move on to the other pair of opposite sides, such as side AD and side BC. So let's find the measure of side AD. It looks shorter. It must be less than radical 26. So A is right here, x1, y1, x2, y2. So let's go ahead and subtract the x values. Negative 3 minus negative 2 squared plus 0 minus 3 squared. Right here, the sign between the numbers becomes positive. Negative 3 plus 2 is negative 1 squared plus 0 minus 3 is negative 3. We are going to square this number. So if we add these together, we get radical 10. Now let's compare this to side BC. x1, y1 here. These two numbers are going to be x2 and y2. So let's subtract them. 2 minus 3 squared plus negative 1 minus 2 squared. So the first one is negative 1 squared plus negative 3 squared. As you see, everything is the same. So the answer is going to be the same. It's going to be radical 10. So now, one of the properties was if opposite pairs of sides are congruent, then the figure is a parallelogram. So this is exactly what we have. We have opposite pairs of sides are congruent, such as, so now we can write our conclusion. We can say, therefore, ABCD is a parallelogram because opposite pairs of sides are congruent. AB is equal to DC and AD is equal to BC. Now we're done with this question, but this is just the method of using the distance formula. Let's move on to the same example, but we are going to use another method, which is the slope formula. So let's get to work then. We are going to use the same example, but this time we are going to use a different method, which is the slope formula. y2 minus y1 over x2 minus x1. So let's remember one of the if-then statements. It was if opposite sides are parallel, like AB and DC, plus AD and BC, then the figure is a parallelogram. So I'm going to show that opposite sides are parallel, which means they have the same slopes. So the opposite sides are AB and DC, right? So let me just write AB and DC here, and also AD and BC. So now let's get to work and then show that these pairs of sides have the same slope. Let's start with AB and DC. Sorry about that. Slope of AB. Now points A and B are here. So x1, y1, x2, y2. So subtract the y values, 2 minus 3 divided by 3 minus negative 2. So the numerator becomes negative 1. 3 minus negative 2 is 5. Now this is the slope of AB. Now let's compare this to the slope of segment DC. DC right here, I'm going to say x1, y1, x2, y2. So subtract the y values, 0 minus negative 1 divided by negative 3 minus 2. It equals 0 minus negative 1 becomes positive 1. Negative 3 minus 2 is negative 5. As you see, these two slopes are the same. That means, let's write its conclusion. Our conclusion, side AB, segment AB is parallel to segment DC. Now, let's do the same thing for side AD and BC. Slope of AD. So I'm going to use these 2 points, x1, y1, x2, y2. Subtract the y values, 0 minus 3 divided by negative 3 minus negative 2. Negative 3 divided by negative 1. So I'm going to leave it like that. So slope of BC is equal to, here is my x1, y1, x2, y2 values. Subtract the y values, negative 1 minus 2 divided by 2 minus 3. It becomes negative 3 over negative 1. So since their slopes are the same, that means the sides AD and BC are parallel. So this gives me the conclusion of having this figure a parallelogram. So therefore, ABCD is a parallelogram. So thanks for watching. That's all for this lesson. If you have any questions, please comment below. I will see you in another video, guys.